Welcome to my channel Chemistry class. Good morning, everyone. Welcome back to chemistry class. My dear student, today we are going to study one of the most important and revolutionary models of the atom, which changed our entire understanding of the atom's structures, which is Rutherford's atomic models. My dear student, Rutherford's atomic models. This model was proposed by Ernest Rutherford in 1911 after conducting a famous experiment known as the gold foil experiment. Now we study the background of Rutherford atomic models or gold foil experiment. What is student? Before Rutherford's J.J. Thomson's plum pudding model was widely accepted. According to Thomson, atom is a positively charged sphere with negatively charged electrons embedded in it like plums in pudding. But Rutherford challenged this with his experiment, which gave us a new vision of atomic structures. Which gave us a new vision of atomic structures. Now, Rutherford's gold foil experiment, a setup of experiment, many student Rutherford took a thin gold foil about 1,000 atom thick. He bombarded it with the alpha particle, positively charged particle emitted from a radioactive element like radium. What is student? He placed a fluorescent screen coated with zinc sulfide around the foil to detect deflected alpha particles. To detect deflected alpha particles. But dear student, this is a Rutherford's experiment apparatus or diagrams. But dear student, an apportion. This is a detecting screen, and this is a gold foil, and this is a alpha particles emitter, and the proportions. Now this is the Rutherford's gold foil experiment apparatus. Now, my dear student, after this, the observations of Rutherford's, most alpha particles passed through the foils without any deflections, and some particles were deflected at small angles, and the third ones were a few particles, 1 and 20,000, bounced back at large angles. Now, Rutherford's conclusions. Based on his observations, Rutherford's concluded the first one, most of the space inside the atom is empty, which allowed most alpha particles to pass through. And the second one, there is a small dense positively charged region in the center of the atom called the nucleus, which repelled some alpha particles. And the third one is electron revolve around the nucleus in empty space. Now, my dear student, key points of Rutherford's atomic models are simply Rutherford's model. The first one, atom has a small, dense, positively charged nucleus at the center, and the second one, all the mass of the atom is concentrated in the nucleus, and the third one, electrons revolve around the nucleus in circular orbits, and the fourth one, atoms is mostly empty space. Now, my dear student, limitations of Rutherford's model. Although Rutherford's model was revolutionary, it had some limitations. According to classical physics, electrons revolving around the nucleus should lose energy and fall into the nucleus. But this doesn't happen. And Rutherford's model could not explain the stability of the atom and did not describe the arrangement of electrons in orbits. Arrangement of electrons in orbit. But during these limitations were later solved by Niels Bohr models, which we will study our next lectures. So, my dear student, Rutherford's atomic model was a milestone in atomic theory as it introduced the concept of the nucleus. My dear student, in our next class, we'll study more atomic models which improved Rutherford's model by explaining electrons' arrangement and atom stability. So, that's all for today lectures. My dear student, if this lectures helped you, then don't forget to like the video, subscribe to the channels, and press the bell icons, and also share it with your friends, and comment your questions or any doubt below. Take care and see you in the next class. Thank you for listening.